derivatives of inverse trigonometric functions. So that is 11th one is y is equal to cos inverse of 1 minus x squared divided by 1 plus x squared. So in this function x is lies between 0 and 1. Okay. So now we need to find dy by dx for this inverse function. So now I'll go with the substitution, that is put x is equal to tan theta. That means in the place of x, if you replace by tan, 1 minus tan square theta divided by 1 plus tan square theta, that is the formula for cos 2 theta. Hope you remember that. Okay. So here is y is equal to cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. Okay. So now y is equal to cos inverse of. So this is the formula for cos 2 theta. Okay. So cos 2 theta. Now cos and inverse get cancelled. Remaining is what? Y is equal to 2 theta. Now y is equal to 2 into theta is nothing but, if I keep it the theta here, then you can take tan this side. Tan will be inverse function. It is a tan inverse of x. Now you can differentiate this and you will get the required dy by dx for this function. Clear? Therefore dy by dx, which is equal to, this is a constant, the product is there, therefore you need to write the constant as it is. Differentiate this. As we know, the derivative of a tan inverse is nothing but 1 divided by 1 plus x squared. Hence you can write a derivative of this inverse function is 2 divided by 1 plus x squared. Hope this is understood. Okay. So 12th one is the same way. So find dy by dx and y is equal to sine inverse of 1 minus x square divided by 1 plus x square. So here is also the same. X is lies between the same value, that is 0 and 1. Again you can go with the same substitution. That is, if you take x as a tan theta, then it will reduce to the cos 2 theta. Now somehow you need to cancel out this inverse function. It will reduce this to the cos, and you need to make it that cos as a sine means you should go with the angle, that is 90 minus theta. Cos 90 minus theta is a sine theta. With the help of that you can make it this is a sine of some angle. Then sine and inverse get cancelled. Then this will be reduced to the simple form. Then you can differentiate that. Is it clear? So now again I will go with the substitution, that is let x is equal to tan theta, then y is equal to sine inverse of 1 minus tan square theta divided by 1 plus tan square theta. So again the same formula, trigonometric formula. So sine inverse of this is cos 2 theta. Now we can't cancel out these two because these two are two different functions. Now I just make it this cos as a sine. So with the help of sine can be written. So sine 90 minus theta is a cos theta. In the place of theta we have a 2. So twice of this. Now we can cancel out the sine and the inverse. And this side we have a y. So y is equal to pi by 2 minus 2 theta. Now you can differentiate. So here let's just write it. dy by dx is equal to pi by 2. This whole thing is a constant. Pi is the some standard value 3.142 divided by 2. Again you will get a real value and it is a constant. Therefore this is 0 minus 2 into. So I just write d by dx of theta is nothing but tan inverse of x. So hence minus 2. Tan inverse x derivative is 1 divided by 1 plus x square. Therefore, a required dy by dx, the derivative of a given inverse function is minus 2 divided by 1 plus x square. Hope you guys understood this. Okay. So now, and move on to 13th. The only thing is you have to remember all the trigonometric formulas. So what we need to take a substitution, and if I substitute that, what we will get the formula. So we should first do that. The 13th one is find dy by dx y is equal to cos inverse of 2x divided by 1 plus x square, where x lies between minus 1 and plus 1. So in this case, so again you can go with the same substitution, that is a tan. So now 2 tan theta divided by 1 plus tan square theta, it is a formula for sin 2 theta. So which is almost the same as the previous one. So here cos inverse is there. So once you apply the substitution, that will reduce us to the sine. You need to write the sine in terms of a cos with the help of 90 minus theta. Okay. So here is, let x is equal to tan theta, then y is equal to cos inverse of 2 tan theta divided by 1 plus tan square theta. Now y is equal to cos inverse of, this is the formula for sin 2 theta. Okay. Now this is cos inverse of, I just write the sign in terms of the cos as cos of 90 minus theta is sin theta. Okay. So now we just cancel out these two, and the remaining is pi by 2 minus 2 theta. So same as the previous one. So now we just differentiate. Before differentiating, we just substitute the theta value. So pi by 2 minus 2 into theta is nothing but tan inverse of x. Now differentiate. Dy by dx, which is equal to, the constant derivative is 0, minus 2 into tan inverse is 1 by 1 plus x square. Hence dy by dx, which is equal to minus 2 divided by 1 plus x square. Okay. So only thing is you should aware of the trigonometric formulas. That's it, guys. So now 14.1. This is an easy one, and you should remember the formulas. Okay. 14.1. Find dy by dx if y is equal to sine inverse of 2x and the square root of 1 minus x square. So now, what will be the x? Now, the substitution. So, almost all the problem we just took it as a tan, but in this case we can't take it as a tan. So, it is a 2 times of the x variable, square root of 1 minus x square. So now, if I take the substitution, then you will come to know. So, what would be exactly? So, x is nothing but, I will just take, either you can take x as a sine, either it is a cos. Okay, you will get the same formula, that is the sine 2 theta. Sine 2 theta is nothing but 2 sine theta into cos theta. So, here if I take x as a sine theta, so this is sine theta and the square root of 1 minus, this is again a sine square. There is nothing but 1 minus sine square is cos square. Square and root get cancel. Again you will get a 2 sine theta into cos theta. Again in the place of x, if you take it as a cos, again it will reduce us to the same formula, that is sine 2 theta. Okay. So in any one of the way you can do it. So I just go with only a sine theta. Then y is equal to sine inverse of 2 into x is nothing but sine theta, square root of 1 minus sine square theta. And this is sine inverse of 2 sine theta. So I'll just go with the trigonometric identity. 1 is equal to sine square theta plus cos square theta. If I take sine that side, it will be 1 minus sine square is, remaining is cos square. So it's nothing but here square and root get cancelled. Remaining is sine inverse of 2 sine theta theta into cos theta. This is the formula for sin 2 theta. Okay, this is the formula for this sin 2 theta, and inverse and a function get cancelled. Remaining is 2 theta. Or you can write 2 into theta is nothing but sin inverse of x. Therefore, dy by dx, which is equal to d by dx of 2 sin inverse of x. And the derivative of this 2 divided by sin inverse derivative is 1 divided by square root of 1 minus x squared. Clear? Okay. So last one. Let us complete this exercise. So 15.1. Find dy by dx if y is equal to secant inverse of 1 divided by 2 x square minus 1. So while going with the substitution, you should remember that if it is a secant, then you just take the variable x as a cos, because as you know the reciprocal, right, means a ratio. 1 by cos is a secant or 1 by secant is a cos. Okay, so here we have a secant inverse. So now if you get it like in this algebraic term, if you go with the substitution, the variable x is a cos, so somehow it will reduce us to some cos standard formula. Then you can write 1 by cos is nothing but secant. So in that case, secant inverse and a secant get cancelled, and you will get the simple form of this. So in that case, you can find the derivative of this. Is it clear? So now, I take the substitution, that is that x is equal to cos theta. Okay. So now y is equal to secant inverse of 1 by 2 cos square theta minus 1. If you remember, the 2 cos square theta minus 1, that is the formula for cos 2 theta. Okay. So now you can write, so 1 by cos is nothing but secant, right? So secant, and here is a 2 theta, and secant and inverse get cancelled. Remaining is what? 2 theta. So now y is equal to 2 into, so theta is nothing but what? It is a cos. So cos inverse you will get cos inverse x. Therefore dy by dx, which is equal to 2 times dy by dx of cos inverse x is nothing but minus 2 times divided by 1 minus x squared. Hope you guys understood this exercise. Okay, so both implicit as well as the inverse trigonometric function in this exercise, both the concept is important for your exam. Clear? Hope you guys understood this. The only thing is, in a derivative of inverse trigonometric function, you should remember the formulas. Okay, trigonometric formulas, then only it will be easy. Only a 3 or 4 step. Within that only you will get the answer. Okay, so next class we'll start with the logarithmic and exponential function and its derivatives. Clear? Thank you guys.